Hello everyone, welcome back to my channel. So, in my previous videos, you have seen the topics regarding constructions of quadrilaterals. Today, we are going to learn a new topic, that is properties of quadrilaterals and polygons. Before going into the topic, I need to clear one thing. In my previous video of practice questions on constructions and quadrilaterals, if you see the seventh question, if you have not watched the video, please go and watch it. If you refer to the seventh question of that video, the question goes on like this. Can you construct a quadrilateral given the measures and give a reason for it? Under the reason, I have given that the sum of the interior angles of the quadrilateral is equal to 60 degree. Please correct it. The sum of the interior angles of the quadrilateral is always 360 degree, not 60 degree. I'm repeating again. The sum of the interior angles of a quadrilateral is 360 degree. Please correct it. I'm sorry for the inconvenience. Yes, let's go for the today's topic, that is properties of quadrilaterals and polygons. Under this, let's learn a first subtopic, that is classifying polygons. Before going into the classification of polygons, we all should know what are polygons, right? So, in geometry, a polygon is a plane figure or a closed shape with at least three or more straight sides. So, a plane figure or a closed shape is said to be a polygon if at least it should have three sides or three or more straight sides. Of course, as a common sense tells, with one side or two sides, we cannot form a polygon. Now let's go to the classification. A polygon is classified based on the number of sides and vertices. As you can see the slide, for example, a polygon with four sides is called a quadrilateral. Yes or no? For example, square, parallelogram, trapezium, rhombus, all these are four-sided polygons or quadrilaterals. If you take, say, five sides, it's a pentagon. Six sides, hexagon. Three sides, triangle. Isn't it? So, based on the sides and vertices, you can name or classify the polygons. Apart from this, polygons can also be classified as follows: concave polygons, convex polygons, regular polygons, and irregular polygons. Let's see one by one. First one, concave polygons. They are the polygons with at least one interior angle measuring more than 180 degree. So a polygon is said to be a concave polygon only if at least one interior angle of the polygon is measuring more than 180 degree. You can see the picture there. There at least one interior angle of the given polygon is measuring greater than 180 degree. Only then it is said to be a concave polygon. Convex polygon is just the opposite to this. No interior angles of the polygon measures more than 180 degree. All the interior angles in a convex polygon is less than 180 degree. Please keep this in your mind. It's just the opposite to concave polygons. Next, regular polygons. They are the polygons where all the sides are equal. A polygon with all the sides are where all the sides are equal is called as a regular polygon. Irregular polygon is just the opposite to it, where no sides are equal in the given polygon. It is said to be an irregular polygon. I have taken few examples here. If you have any other examples in your mind, please tell me in the comment section. Diagonals of a polygon. Now, what are these diagonals? We all are familiar with this word diagonals. What are these? These are the line segments which are drawn or by joining two non-adjacent vertices. The non-adjacent vertices are those vertices which are not next to each other. We can draw the diagonals in a polygon by joining these two non-adjacent vertices. Now, you may be wondering that, say, you draw a polygon randomly, right? And you know the number of sides of it. But you're not able to predict or analyze that how many diagonals this particular polygon can have, right? So we have a very simple formula here. Given that the number of sides of the polygon, you can, by using this formula, predict the number of diagonals of the polygon. The formula goes like this: n into n minus 3 by 2. Say you have a polygon with 6 sides. You can try with as many sides you want. Okay, it works. So we have n is equal to 6 here. So 6 substitute in the given formula. 6 into 6 minus 3 by 2. First, according to Bodmer's rule, solve the equation given in the brackets. 6 minus 3 is 3. 3 into 6 is 18. And 18 by 2 is 9. So how many diagonals can a 6-sided polygon have? That is, a hexagon have 9. So like this, if you know the sides of the given polygon, you can predict the number of diagonals. Here, which polygon is this? Name the polygon. How many sides are there? 1, A to E is 1, A to B, E to D is 2, D to C is 3, C to B is 4, B to A is 5. So, 5 sides. Predict the number of diagonals now. Substitute again. 5 into 5 minus 3 by 2. 5 minus 3 is 2. 2 into 5 is 10. And 10 by 2 is 5. Yes. So, this is a pentagon as there are 5 sides and the number of diagonals are 5. 1, 2, 3, 4 and 5. See? And this is a convex polygon where all the diagonals in a convex polygon lie inside the polygon. Now, see here. In case of a concave polygon, what happens? At least I say always, convex, the opposite to convex polygon is a concave polygon. There you can see all the diagonals lie inside. Here at least one of the diagonal lies outside the polygon. This is for a concave polygon. Remember this point. Hope you have understood whatever I taught now. Let's go to the practice questions. First one. Choose the concave polygons. Now, you can see there are 4 different polygons given to you. From these 4, we need to choose one or more than one which are representing the concave polygons. Now, you tell me if a polygon has to be a concave polygon, what is the first condition? At least one interior angle in that given polygon should be greater than 180 degree. By looking at the figure itself, we can say. Now take option A. Is there any angle which is measuring above 180 degree? By looking at the figure, we can say that it is no. It is not representing that at least one interior angle is 180 degree. Look at B. It is, right? There you can see the outside angle, the inside angle, one interior angle is representing greater than 180 degree. Similarly with option D, A and C are not representing concave polygons. So whenever you have asked such type of questions, look at the figure and predict. So option B and D are the correct answers. Second question. Draw a convex octagon and all its diagonals and write the number of diagonals drawn. Now, before drawing, you all know that we have all learned the concept, right? If we know the number of sides of the given polygon, we can predict the number of diagonals. So let's go to the second part of the question now. Write the number of diagonals drawn. How many diagonals can an octagon have? Tell me. Octagon, how many sides are there? 8 sides. Very good. An 8-sided polygon is called as octagon. Now we know the number of sides, 8. We know the formula also. N into n minus 3 by 2. 8 into 8 minus 3 by 2 is how much? 8 minus 3 is 5. 5 8s are 40. 40 by 2 is 20. So an octagon or a convex octagon can have 20 diagonals. Now, let's go to the first part of the question where you should draw a convex polygon. This is a convex octagon. So there are 20 diagonals basically. I'm showing you one by one. If you count carefully, there are 20. How many there in this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at the figure carefully. I'm showing you one by one. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. See, you got all the 20 there. If you are still unable to find it out, you can watch the video again. I have represented all the 20 diagonals. Or you yourself draw the octagon neatly on a plain paper and draw the diagonals. You will get 20 diagonals definitely. See, I have shown you the workout here. So therefore, number of diagonals drawn in a convex octagon is 20. Last question. Draw all the diagonals in this concave hexagon. Now, last question was the dealt with the convex octagon. This question we are going to deal with concave hexagon. We learned about concave polygons, right? Where one interior angle is greater than 180 degree. Whether it's a concave or a convex polygon, drawing diagonals, applying the formula is same for all the polygons, whether it's irrespective of the type of which it is. Now again, concave hexagon. Now tell me how many diagonals can a concave hexagon have? Hexagon, right? So if it's a hexagon, how many number of sides? 6. Apply the formula. 6 into 6 minus 3 by 2, which is 6 minus 3 is 3. 3 into 6 is 18. 18 by 2 is 9. So basically 9 diagonals this convex hexagon, that's A, B, C, D, E, can have. If you still can't understand, again draw it in a plain paper. Draw each diagonal, you will get 9 diagonals. See, I have shown here one by one. See, as I told you, for a concave polygon, at least one diagonal will be outside the polygon. See, there is one diagonal just lying outside the polygon. And these are the diagonals lying inside the polygon. Hope you have understood today's topic. Thank you everyone. See you in the next video.